Hi guys, so today we're going to continue looking at parabolas. We're actually just going to do the opposite though of what we did last class. So last class we took the equation of a parabola and we sketched the graph, or we found some information like the focus and the directrix. What we're going to do instead this time is we're going to take some information and we're going to write the equation of the graph. So in order to do that, we're going to review some things from Algebra 1, and some of those things are going to be just the forms of a quadratic equation. So there were a few of these that you guys looked at back in Algebra 1. The first one was standard form. So standard form is the one you probably saw most often whenever you're using the quadratic formula. So that was ax squared plus bx plus c. Then another one that we've really already seen is vertex form. And vertex form is the one that makes it really clear what your transformations are. It also makes it very clear what your vertex is. And the last one is either root or factored form. And what that is that makes it really clear what your x-intercepts or your zeros are. Because if you remember, the root of your equation, that's the same thing as the zeros. Another word for that is the x-intercepts. You also will hear it referred to as the solutions. So those are all the different forms of your quadratic equations that you guys have seen so far. Then I'm going to go ahead and add the two that we did last class. So last class we started looking at parabolas as conics instead, because we were starting to look at parabolas that weren't functions when we introduced those horizontal parabolas. So the equation that we looked at then was y equals 1 over 4p x minus h squared plus k. And if you notice, I wrote it really close to vertex form for a reason, because that equation is almost the exact, well, it is the exact same equation as vertex form. It's just different in the way that we write it, because we're writing it with that 1 over 4p. And the reason that we're doing that is just because it makes it really easy for us to identify then what our focus and our directrix are. Or if we're writing the equation from that information, it makes it easy for us to know what it is when it's plugged in. Now, if you were to actually see an equation in that form, it would not look any different between those two. Those two would look like the exact same equation. It's just a matter of how you're interpreting that first value. What A is helpful for, A helps us to determine, hey, what's my vertical compression? What's my vertical stretch? Is it reflected over the x-axis? Whereas 1 over 4p makes it really clear where is my focus and where is my directrix. So those two equations are actually going to look the exact same in practice. Now the other equation that we looked at, if we're trying to find focus and directrix, was just if it's horizontal, and that one is a little bit different, because if it's a horizontal parabola, it's no longer a function. So we were looking at this equation here. Very similar, but you'll notice it's x equals and it's y squared, and then the k and the a are switched. And the k and the a are switched intentionally because the k is the y coordinate, so it's next to the y value. But again, as we talked about in class, that k and that h in that equation, that tends to be the thing that's missed the most often and the most forgotten about. So I'm just going to go ahead and label that. So we said that those were basically, it's really the conic form. But really, those are the forms that help us when we're trying to find or when we know the focus and the directrix. The one on the left is what we use if it's a vertical parabola that opens up or down. The one on the right is what we use if it's a horizontal parabola and it opens left or right. All right, so now let's go ahead and look at that first example. So we're going to write the equation of a quadratic function in vertex form that has the following features. So the first one gives me the vertex and the focus. Well, since it gives me the vertex and the focus, I'm going to use one of these two equations because those are the equations that are easiest to use when you know the focus or the directrix. So in order to figure out which way this opens, I'm just going to sketch a quick graph. I think it makes it easy to see. So there's my vertex. And then the focus is at -1, 1, which is down there. Well, since the vertex is above the focus, and your graph has to open towards it, this graph is going to open down. That means it's going to be a vertical parabola, so y equals 1 over 4p x minus h squared plus k. We can go ahead and then fill in the information that we know. Well, the first thing we need is the p-value. So p is the distance between the focus and the directrix. So in this case, that p-value is 2. So when I plug that into my equation, it would be 1 over 8. Then my vertex, x plus 1 squared, then plus k. And that gives me the equation of my vertex and focus with that we're given. So sorry guys, I'm using a different program here to do the video, so I know the pens are doing some weird things. I'm still kind of adjusting to it. All right, the second one, that one gives us a lot of vocab. So on this vocab, we need to determine what we can figure out. Well, it tells us the axis of symmetry is at x equals 2. And we know the axis of symmetry has the same x coordinate as the vertex. It tells us the range is negative infinity to -4. That means your graph is going to open this way, and that would be my vertex at the top. The highest y value then, or the k value, would be -4. It also tells us the y-intercept is -12. So this graph is going to go through 0, -12. So let's go ahead and fill in the information that I know out of vertex form. And again, this equation is going to look very similar to the last one. The only reason it's vertex form is just we're using that a value instead of the 1/4p, just because in this particular example, focus and directrix is not going to matter. All right, so this is going to be y equals a x minus 2 squared minus 4. Now, in order to have this equation, I need to know what that a value is, and I don't know what that a value is. What I do know, though, is another point that this graph goes through. So since this graph goes through 0, -12, that means when I plug in 0 for x, I'm going to get -12 as a y. And I can use that information then to solve for that a value. So I can go ahead and add 4. -2 squared would be 4. So then when I divide, I would get that a is equal to -2. So now that I know what a is, I can go back to my original equation that I had and just replace that a with -2. And I get my equation. All right, so let's go ahead and look at the next example. Very similar to the one we just had, just written in a different way. So I know the vertex, so I'm going to use vertex form. So that's going to be y equals a x minus h squared plus k. So filling in the information I know, x minus 4 squared minus 1. And I don't know the a value, so I'm going to plug in the values I do know. Well, f of 3 is equal to 6. That means when x equals 3, y equals 6. So that's the point that this graph goes through. So I can go ahead and plug those in. And solve for a. So add 1. -3 minus 4 is a -1. -1 squared is 1, which tells me that a is 7. Well, if a is 7, then that means the equation of this graph is going to be the same thing that I had before, except instead of a, I can now replace that a with 7. All right, looking at my next example, again, very similar. So if you feel comfortable, pause the video, try this one on your own. All right, so we're going to use vertex form. Fill in what I know. And then the root is 4. So remember, root is another word for 0 or root. Oh, sorry, there it is, root. 0 or x-intercept is another word for that. That means the coordinates at that point would be 4, 0. So if I plug in 0 for y, so 4 minus 6 is -2. -2 squared is 4. That gives me an a value of 1/4. So I can go ahead and plug that into my equation. So I would get 1/4 x minus 6 squared minus 1. All right, so in this next set, our final answer is going to be in standard form. Now, that does not mean that we're going to start with standard form necessarily. In some of these cases, we will, but we may need a different form to start with in order to then get our answer in standard form. So on this first one, it gives me the zeros, and then it gives me another point on that graph. Well, since it gives me the zeros, then I'm going to use root form, because root is another word for zeros. So y equals a, x minus the first root, x minus the second root. So this would be x minus 2, x plus 5. Again, we don't know the a value. So in order to determine what the a value is, I need to take the x and the y and plug them in and solve for a. So I would get 4 equals a, 3 minus 2 times 3 plus 5. And then 1 times 8 would just be 8. So a would be 1/2. So when I plug that in, this gives me my answer in root form. However, the question wants the answer in standard form. So in order to put this in standard form, what I need to do is I need to multiply this out. And that means I need to FOIL that binomial. So if you remember, FOILing is first, outside, inside, last. And then I'll go ahead and simplify that up here. So that's going to be x squared plus 3x minus 10. And then don't forget, this entire equation was then multiplied by 1/2. So when I distribute that, that gives me my equation in standard form. So even though I wanted my answer in standard form, I didn't start there just based on the information I was given. I started in root form, then I solved, and then I just simplified in order to put this into standard form. All right, let's look at B. B is very similar. It gives us an x-intercept, so I could use root form. But what I also could use actually is vertex form, because it tells you the only x-intercept is 2. Well, if the only x-intercept is 2, that means that point has to be the vertex. It's either going to open up or it's going to open down. In this case, we know it's going to open down because the y-intercept is negative. But either way, we know that the k value of my vertex is 0 because it's on the graph. We know the h value of my vertex now is 2, since that's the only x-intercept. So I'm going to go ahead and write this in vertex form. So now, just like we did on those previous questions, I need to go ahead and plug in my value that I know in order to solve for a. Well, in this case, I know the y-intercept. The y-intercept is negative 12. That means that this graph is going to go through the point 0, negative 12. So if I plug in negative 12 for y, then I can solve for my a value. So negative 12 is equal to 4a. So a is equal to negative 3. That means in vertex form, my equation would look like this. The problem is it wants it again in standard form, so I'm going to need to FOIL this out. And again, I did say FOIL it out. We do actually need to FOIL it. A super common mistake that happens is a lot of people, when they see this squared here, is they just want to distribute that squared. We cannot do that. That's not actually what this question's asking. Whenever you see a binomial that's squared like that, what you're actually being asked to do is multiply x minus 2 times x minus 2. And you'll notice that actually looks like root form now. But we have to remember, if you see a binomial squared, you cannot just distribute that square to both those terms. It's not going to give you the same thing. Because when I actually FOIL this out, I'll get x squared minus 2x plus 4, which is actually x squared minus 4x plus 4. Then I can go ahead and distribute that negative 3, which would give me my final answer of negative 3x squared plus 12x minus 12. All right, the next few examples are probably the hardest ones algebraically because they're both going to actually involve systems of equations. So on this first one, it gives us 3 points. So since it gives us 3 points and it doesn't tell us a vertex, we can't use vertex form. We don't know any roots, so we can't use root form. So what we're going to have to do is use standard form. So standard form was y equals a times x squared plus bx plus c. And we don't know a, b, or c. That means that I have 3 variables. Well, in order to solve for 3 variables, like we did in the last unit, I need 3 equations. So I'm going to go ahead and write what those 3 equations are. Well, I'm going to start with the first x and y. So if I plug in 1 for y, then I'll plug in 0 for x. And then I'm going to go ahead and simplify that equation. Well, that equation is going to simplify this to 1 equals c. So that's equation number 1. Equation number 2, plug in x and y. So 10 equals a times 9 squared plus b times 9 plus c. So 10 equals 81a plus 9b plus c. That's equation number 2. Equation number 3, take the last x and y. So 25 is equal to a times negative 6 squared plus b times negative 6 plus c. So 25 is equal to 36a minus 6b plus c. And that is equation number 3. So now I have 3 equations and I have a 3-variable system that I can solve. Well, what's nice about this one, it's going to be a little bit easier to work with because I already know what c is. So what I'm going to do then is I'm going to go ahead and take that c value and I'm going to go ahead and plug it in to both c's in those other 2 equations because this one's actually going to work out really nicely and simplify pretty well for us. So when I plug in c on this equation, that's going to now be 22. Oops, sorry, I'm thinking of a different problem. That's going to be 1. That'll be a lot easier to work with. And now if I try and rewrite this equation to put it in more of that standard form, if I subtract 1 from both sides, I would get 9 equals 81a plus 9b. Well, what's really nice about that equation, you'll probably notice, is all of those numbers are divisible by 9. So I can rewrite that equation again, just divide everything by 9, and then I have a much easier equation to work with. Well, now we're going to do the same thing on equation number 3. I'm going to go ahead and plug in one for c, rewrite the equation, and you'll notice now all those numbers are divisible by 6. So go ahead and divide them all by 6. And now I have, again, a much easier equation to solve. So now I have a new system. My new system is 1 equals 9a plus b, and 4 equals 6a plus b. I'm sorry, that was a minus b. And again, very easy system to solve because those b's are going to cancel out. And I get that a is equal to 1/3. Once I know what a is, I can take it, I can plug it in. So I get that 1 is equal to 9 times 1/3 plus b. So 1 is equal to 3 plus b. So b is equal to -2. I already know what c is. So then to write this equation in standard form, it's going to be y equals 1/3 x squared minus 2x plus 1. All right, equation number 2, or sorry, example D here. This is also a systems question. Now this one's going to be a little bit easier in terms of the system, but this one's actually one of the hardest ones just to figure out how to solve. We're actually going to start off in vertex form on this one, just based off the information I know. Because the only information I know besides those 2 points is the axis of symmetry. And the axis of symmetry is our h value. Well, in order to have something in vertex form, then I need to know both the a and the k, which means I have 2 variables. Well, since there's 2 variables, I need 2 equations. So I'm going to plug in x and y. And that's equation number 1. Take that same content, plug it in over here. And I get 20 equals 100a plus k as equation number 2. Then again, in order to solve this, I would just rewrite that new system. I can eliminate k and substitute it back to get my other values. Now this one works out to be kind of some ugly fractions. So if you work this one out on your own, I'll go ahead and put the answer up. But this one, again, my a ends up being 1/7. And my k actually works out to a very ugly 40/7. All right, so now on this next one, what we're going to do, is write our equations based off of our transformations. So on this first one, it gives us the parent function to start off with, and it tells us some transformations that are happening. These are very similar to some questions we saw with absolute value. So on the first one, it says it has the parent function. We're going to shift left, then we're going to vertically compress, and then followed by a shift up 1. So to write the first part, shifting left 3. Well, in order to show that this graph is being shifted left 3, then what I'm going to do is take that x and do plus 3 inside the parentheses. Then the next part, it wants me to vertically compress by a factor of 2/3. That means I'm going to take whatever equation I have, and I'm going to multiply it by 2/3 on the outside. Then the last part, it says followed by a vertical shift up 1. So the next step that I would do, a vertical shift up, would mean I would take the function that I have and add 1. So my new equation would look like this. All right, the next one, a little bit trickier because it has a horizontal compression. And like we talked about, horizontal compressions are one of the most missed transformations. So if there's a horizontal compression by a factor of 3/4, 3/4 is not the number that goes in my equation. The number that goes in my equation inside the parentheses would be 4/3. Then it says it's shifted down. So my next transformation then would be -3. Then it says followed by a reflection over the x-axis. Now, whenever I write this, the order that we're applying the transformations in matters. In order to reflect over the x-axis, and that was not a highlighter, in order to reflect over the x-axis, I have to take that function and make the entire function negative. So I'm going to take the function that I have and make that function negative, which means I'm going to get a negative 4/3 x squared, but now it's no longer -3, it is now +3. So let me rewrite this. So g of x is negative 4/3, negative 4/3 x squared, and it is now +3 because that negative happened after. So again, the order you apply these transformations in matters. All right, on this next one, we're going to start with the function x minus 2 squared. So we're not starting with the parent function. Well, the first thing it says is vertically stretched by a factor of 3. That means I'm going to take that function and I'm going to multiply it by 3. Then the next thing it says is to shift it left 7. Well, left 7 is normally +7 inside the parentheses. Well, I need to add 7 to what's already there in the parentheses, so now it's going to be +5. And that is my new g of x function. All right, on this last one, what we're going to look at, this one's a little bit different because it's not in that vertex form where the transformations are easy to see. So what I need to consider is what these transformations look like in function notation. So if this is shifted 3 units right and 2 units up, when we learned about function notation at the very beginning of the year, that means, keep using the highlighter. That means that it's going to be f of x minus 3 plus 2. So I need to apply that transformation to my equation. So f of x minus 3 means I replace x with x minus 3. Plus 2 means I just take that whole function and add 2 at the end. Well, now I'm going to go ahead and FOIL this out. Remember, x minus 3 squared means x minus 3 times x minus 3. So that's x squared minus 6x plus 9 minus 5x plus 15 plus 2, which all simplifies to x squared minus 11x plus 26. Then the last transformation, it says after that's all done, it then says reflected over the y-axis. So now that that's done, reflecting over the y-axis means f of negative x. F of negative x means you replace all of your x's with negative x. So this becomes just x squared plus 11x plus 26. So this is your new function. All right, so the last thing we're going to look at is just looking at graphs and then writing the equation from the graph. This is exactly what we did in all of those early examples. The only difference is it doesn't tell you what information to use. You just need to determine based off the picture what's going to be the best information to use. So on the first one, for example, we can't really see any clear points besides the vertex, but I can see the directrix, which means I'm going to want to write this using that conic form. Since it opens left, I'm going to use x equals 1 over 4p y minus k squared plus h. Well, I can see the vertex. The vertex is 0, 6. I can see the directrix. The directrix is x equals 5. So since I know the vertex and the directrix, that means that the p-value is 5. So my equation then would be x equals 1 over 20. And since it opens left, negative y minus 6 squared. My h value in this case is 0, so I can just leave it there. On my next one, again, I can see the vertex pretty clearly, so I'm probably going to use vertex form here. That vertex is 2, negative 1. So y equals a x minus h squared plus k. So I would do y equals a x minus 2 squared minus 1. And then you can pick any point on this graph that you want to plug in. Solve for your a value. You're going to get an a value of negative 1/3. So y equals negative 1/3 x minus 2 squared minus 1. Now what you could do on this one instead is you can consider how this function has changed from the parent function. Well, we know in the parent function we normally go over 1 and up 1, over 2 and up 4, over 3 and up 9 from the vertex. Well, we obviously know this graph opens down, so it has to be negative. But normally, I would go over 3 and down 9, but I went down 3. Well, the change that is a change of 1/3. So going from 9, in order to actually go down 3, I would have to multiply by negative 1/3 in order to get to that location from the vertex. And that's another way that you could find that a value from the graph. All right, and this last one here, again, it's kind of hard to see the vertex. If you want to try and guess it, you might have a hard time, but just remember the vertex will be halfway in between those two roots because of the axis of symmetry. But again, since I know my roots, I would probably just use root form here. Plug in any point that you want. For example, I could plug in 1, negative 8, and then I could solve for a that way. If I did that, I would get my a value of 8/3. I can go ahead and distribute. And then I can distribute that as well if I wanted to write this in standard form. All right, so that is writing equations of parabolas. Out of all this, probably the biggest thing you're really going to need to know are those different forms of the equation. Depending on what information you have is which equation is going to be the easiest for you to work with.